Alright, we're at GoToMath.com working some calculus. We're evaluating limits numerically, and we're in this section here. If I can get number 3 to come up in this section. There it is. Alright, that's the one we want to look at. Alright, so we got to evaluate the limit numerically. We got the limit as x approaches 2/9. Now, sometimes this fraction right here is not reduced down, so that's a little tricky thing. You need to reduce that down before you actually evaluate it, alright? Okay, it says 81x squared minus 4 over 9x minus 2. So let's head over to the whiteboard and check out how we want to do this numerically. So we have the limit as x approaches 2/9. Like I said, sometimes that fraction is not reduced down, so you need to go ahead and reduce it, if you will. We got 81x squared minus 4 over 9x minus 2. Alright, I'm going to write this like I have in the other problems in this section and the previous section. And of course I know f is overrated. And we're going to factor this thing, cancel some like terms out. It's kind of important because of the next section, but helps us utilize, or it helps us guess what this graph kind of looks like. It's hard to look at that and go, hey, I know what the graph looks like. And of course, you know, the question could be asked, this could be asked. Find the limit as x approaches 2/9 of f of x, and then somewhere else on the page they give you f of x, alright? So either way could be asked, and I think it's important that you need to know that. Alright, what I'm going to do here is I'm going to go ahead and factor this guy, and we're going to look at a different, well, it's not a different function. It's going to be the same function, but it's going to look different. This actually here can be written as 9x quantity squared minus 2 squared over 9x minus 2. Alright, this is the difference of two squares, and it can be rewritten as 9x minus 2 times 9x plus 2. And it's all over 9x minus 2. Now we can cancel some stuff out here. Got a term in the top, term in the bottom that's actually the same. So we can actually get rid of that. Now I'm labeling this as f, and right now, finish here, this f and that f are obviously two different functions, right? They're two different f's. But if we came over here and stated, okay, x cannot be equal to, let's see, what do I need to put in here to get to 0 here? 2/9, 2/9. Okay, x cannot be equal to 2/9. Well, then we can say that this f and this f are actually both the same, as long as they have the same domains. Okay, these guys have the same domains, and therefore they're equal. Now we can actually attach a graph to this. Of course, you know, this is all just a bunch of extra stuff here to try to get you to better understand what is going on. And has a slope of 9, cross of 2, you know, we'll say it's something like that. And of course 2/9 we'll say is there. Of course this thing's not to scale, but anyway, there's 2/9. Okay, if I was asked to find f of 2/9 in this guy right here, if you plug 2/9 in, we'd get 0 of 0, therefore it breaks down. So we're not going to know. We want to know, where is this hole located? What is the y value associated with this hole right here? Well, we don't know by just taking this number and plugging it in. But we could come over here and ask our friend the limit, and he will actually tell us what this y value actually is, which I'll just call L here. Our friend the limit could tell us, but our friend f over here, he don't know. He breaks down all his mechanisms and his machinery, man, goes haywire. But the limit guy, he can tell us where this hole is at. And the way we're going to actually do this is we're going to do it numerically. And there is another method that we can do this, but we're going to do this numerically right now. Okay, that's if we couldn't factor this thing. And anyway, and the way this works is it's really simple. What we're going to do is we're going to take a number that's to the left of 2 9ths. All right, and then we're going to get closer and closer and closer. And that means we're going to take 2 9ths and let's subtract off 0.1. All right, take 2 9ths, subtract off 0.1, get some number, then do it again. And basically what this means here is we're getting closer and closer to 2 9ths coming in from the left hand side, and that means we're getting closer and closer to wherever this hole is located. And then we continue to do that. Now let's come in from the right hand side. I'm running out of room here. We'll come in from the right hand side, so that means we're going to take 2 9ths, we're going to add 0.1, alright, to it, and then f of 2 9ths, we're going to add 0.01. Okay, so what that means is we're coming in from the right hand side, getting closer and closer to 2 9ths coming in from the right hand side. So that's all we got to do. We just come in from the left, get closer and closer, check out what this y value is converging towards. Let's actually move over here to the web page and see how this actually works out. Alright, so as you can see here, we're approaching 2 9ths from the left, so we have f of 2 9ths minus 0.1, right, and you get 3.00. Now I know this is going out to a lot of decimal places, but you know, just bear with me on that. I wasn't going to fix this to some decimal point here. We'll just let the JavaScript do that for us. But anyway, this is okay. And then, so as you can see here, we're coming in, getting closer and closer to 2 9ths coming in from the left hand side. We can get an idea. We got 3.1, 3.9, 3.0 is what I meant to say, 3.9, 3.99, and so you can kind of guess maybe what we're converging in on. And then, of course, coming in from the right hand side, we got 4.8, 4.09, seems to be a big jump there, and then 4.009. So as you can see here, this looks like it's getting closer and closer to 4 coming in from the left, and this looks like it's getting closer and closer to 4 coming in from the right hand side. So my guess is that's probably what it's going to end up being, is going to end up being 4, and of course it is. Right? So there it is, and that's where we're at. Go to math.com. See you there.